Good morning. Welcome to the 39th lecture on economics, management and entrepreneurship. In our last lecture, we had discussed plant location factors and how to decide among alternatives to locate a plant at a particular location. We had indicated then that the next logical topic to be covered is facilities layout or plant layout. But today we shall first discuss product service strategies that an enterprise should follow before discussing the topic on plant location. Thus, today two topics will be covered. The first topic is product service strategies and then it will be followed by plant layout. So, today's topic to start with is product service strategies. Basically, there can be at the two extremes a custom products or services or standardized products or services. When we say custom products, we mean the customer decides the specifications of the products or services that he or she desires to acquire, and the enterprise therefore has to keep its facilities ready to produce that product or service and deliver it to the customer. A particular customer's product or specification would be different from another customer. Therefore, such custom products or services are really very challenging for the enterprise. Whereas, if it is a standardized products or standard product, then the operations are very well known to the enterprise and therefore, it can plan its facilities, it can acquire facilities and it can arrange the facilities in a pre-decided manner, such that the product can be made to even stock, so that when a customer demands it, such a standard product can be delivered to the customer with very little time, at very little time. So, this is the two extremes of the products. We call them custom products or services and standard products or services. Usually, products that are consumed are standard products, whereas products that are demanded by the producer goods such as machine tools are custom products. Custom products examples could be a ship or an aircraft, in which case the customer says that this is the requirement, this is the specification, or even small jobs with specifications specified by the customer. The emphasis is therefore on uniqueness, and there the difficulties arise because of unique demand on delivery time, quality, and the enterprise must be flexible enough to address different specifications of products desired by different customers. Standard products are ideal, very little difference between products. Normally, variety among the product designs is very little, and certain services are also possible to get in standard forms. Insurance procedures, motor vehicle registration, even fast food services can be standardized. Now, normally we use a word or a term production system. Basically, it is a man machine complex that transforms input of material, information, power, and it produces outputs such as products or services. In a manufacturing environment or in the context of manufacturing system, we call it a production system. Now, an enterprise could be product focused or it could be a process focused. Now, highly standardized products or services are usually product focused, and because the products or services are standardized, the production system is in continuous use, and normally the production is in high volume and one can engage specialized machines to do specialized operations. And since a product is standard, its operations are known, and therefore, the machines or the individual processing units can be arranged in a sequence or in a line, and this enables the company to go for high level of mechanization and automation. And normally, a marketing strategy is to produce to stock, whereas in a process focused system, custom products or services, they are each one is of a different type. Therefore, the enterprise must have processes that are so flexible that it can handle a variety of customer products or services, and production system is not always in continuous use, it is in intermittent use. That means, certain facilities may remain idle for a while, and the physical facilities are normally arranged around the nature of processes, and therefore, they form a department, such as milling machine could form a department, lathes could form a department, or even in service organizations such as hospitals, X-rays could form, X-ray machines could be in one department, and all pathological labs, pathological experiments or tests can be carried out in a lab, pathological lab. Therefore, the personnel are specialized by generic process types. Say for example, somebody is good at milling in a milling machine department. In an X-ray, somebody must be very specialized in taking X-ray, etc. Now, normally the actual situation could be different. It may not be, it may be a low volume multiple product case. A company may be dealing with similar products of different specifications, say different brands or different volumes. So, it is a low volume multiple product case, and they are produced in batches rather than in mass. For example, a company that produces refrigerator may produce refrigerator of different capacities. It may have 5 different brands of refrigerators. Therefore, each it can produce in batch. Say for example, a capacity C1, it produces 100 in one batch, it may be followed by refrigerators of capacity C2 of 200 in number. Thus, the production machines must be geared up or must be set up to produce 100 refrigerators of capacity C1 to start with, and then the setup must be changed to produce refrigerators of capacity C2. Now, this is normally the case when there are multiple products of similar nature and they are of low volume. Now, sometimes we have high volume multiple product case. In such a case, normally what is happened, parts are produced in a process mode. That means, parts are produced in different departments, whereas they are assembled in a product mode, that means in a line fashion. Now, in a company, therefore, the strategy the enterprise should take would depend on two things. One, the product life cycle stage, at which stage of the product life cycle the product is now operating. Normally, if it is at the introduction phase, then it is a low volume and probably it is a custom products or services. Whereas, if it is on the saturation on the or decline phase, probably it is high volume, but standard products. Therefore, product service strategies would depend on the stage in which the product is passing through in its life cycle. Then also the strategies will depend on the whether it is multiple products, low volume or high volume single product. If it is custom products, each specification of the job or order is different, then that shop is known as a job order shop or a job shop. Each job is different, it follows a process strategy. Whereas, if it is a single product, but very high volume, it is a product focused enterprise, where every operation, every machine or equipment is utilized continuously. Between these two extremes, as we have already mentioned, there is a batch processing, low volume multiple products, or mixed processing, in which high volume multiple products cases are there. Now, the enterprise will naturally has to decide where to operate, and this is the preferred path. Actually, the path is not such a straight line path, there is a band of choices. The band varies from here that emphasize flexibility and quality, that is low volume custom products, to choices that emphasize low cost and high availability, that is mass production or continuous production. So, the company can operate here, 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 here or here in this band. So, basically here we said that a company has the choice of deciding the products depending on the stage in which the products are passing and the volume or volume of demand and the nature of demand from the customers. So, it has the choice of deciding whether to go for intermittent production or continuous production, and in between these two extremes we have batch production or mixed production strategy. Now, the company can decide where to position itself, whether to go for product focused system and then the strategy could be to make to stock. Sometimes if in a process focused system, producing spare parts may in fact go for a make to stock policy, because spare parts are something without which a machine would remain idle. Therefore, whenever a machine is idle, the owner of the machine would like to get the spare part as soon as possible. Therefore, although the spare parts demand is not continuous, the manufacturer of the spare parts would like to keep an inventory of spare parts in its stock, so that the customer's demand is met immediately. So, even a process focused system whose output is spare parts may go for a policy of make to stock. And if it is a process focused system in which the custom orders are normally obtained and it is intermittent in nature, it is usually make to order. You produce only when there is an order. However, there are situations where if in a product focused system such as that which manufactures machine tools following a particular sequence of operation, may even not produce a machine tool because it is very expensive to make one unless there is an order. So, it can follow a policy of make to order. Now, before we close this topic, we would like to discuss a few things about how from the customer order reaches the enterprise or the factory. On the right hand side is the customer, and on the left side is the factory and its warehouse. This dotted line shows the flow of orders and the farm line shows the flow of material. Customer places the order at the retail for its goods. Retailer fills the order. So, this is order filling delay. There is some delay in filling the order and then it supplies to the customer. There is a transportation delay here. This delay could be of the order of 1 day to 1 week. This delay depends on the inventory that is available with the retailer. If the customer demand for the product, if the product that the customer demands is available in the inventory of retailer, the delay in supplying it is not much here. The delay could only be in the transportation, but if it is not available, then it places an order for replenishment to the distributor. There may be a small amount of delay here, which is what I am saying is order decision delay, some delay, and then there is a mailing delay here. If it is sent by normal post, today the mailing delay could be much less because of electronic mailing system, but there is a delay in deciding when to replenish the stock, and the distributor once again passes through the same thing. Depending on its inventory position, there is a delay in making the supply and there is a transportation delay from the distributor to the retailer, and then the distributor's stock falls and it decides to replenish it. That is the decision delay to replenish the stock. It places an order, there is a mailing delay, then it goes to the factory warehouse. Factory warehouse once again supplies the material if it is having, and then when factory warehouse's inventory is less, it places an order with the factory production rate, and then the factory produces it. So, this is the production delay, and factory supplies it to the factory warehouse supplies it to the distributor to retailer, and finally retailer to the customer. So, this is the way in which the production distribution system works. So, up till now we said that a company, depending on the stage in which the product is passing through its life cycle, and the nature of the demand, low volume or high volume, and custom products or standard products, it can position itself to decide whether it should be product focused or process focused, and whether it should go for make to stock or make to order. With this background, we now see the aspects of plant location. Before we do that, we just would like to say that in this production distribution system, in this supply chain, of course, this is the supply to the customer, the outbound supply. Here there are certain inventories that are piling up. One is called the pipeline inventory. This forms in fact a pipeline. The whole of it is a pipeline. There is a transportation delays. So, there are some items that are held up in transportation. There are some items that are held up also in the order filling delay, and the average customer order rate, when it is multiplied, that is called the pipeline inventory. There are two types of inventories also apart from pipeline inventory, that is called cycle inventory and buffer inventory. Cycle inventory is the inventory that a particular unit has before it orders for replenishment. So, it is the average time to reorder into average customer order rate. And apart from the cycle inventory, the unit also holds certain buffer inventory, which is basically to guard against the risk of stock out. That depends on the maximum demand during lead time minus the average demand during the lead time. These aspects of cycle inventory and buffer inventory we shall discuss in detail when we come to inventory control topic. So, for the time being, we are going to the discussion on the plant location layout factors. Like plant location, plant layout is almost a one time decision, and it influences particularly the cost of transporting parts, sub-assemblies, components, etc., inside the factory. So, plant layout basically says where the machines should be located. So, naturally, the location of the machines inside the factory shop floor would depend on the most likely operation sequence. And in a product focused approach, the operation sequence is fixed, and therefore, the problem there of plant layout is different from a process focused system in which the products are different, and therefore, the sequence of operation is also different from one product to another. Let us see these complexities of plant layout in detail. Plant layout. A small definition is that it is concerned with physical arrangement of the production facilities. Thus, it involves allocation of space and the arrangement of facilities, and it influences material handling cost, and it also influences time to produce and the extent to which the space is utilized. Plant layout needs arise when an enterprise goes for a new plant, or it produces a new product, or the design of the product undergoes a drastic change, or because of the volume of production going up, a new machine is to be installed, or a new machine more capacity and a more efficient machine is being installed instead of the old machine that which is to be taken out, or there can be certain machines that are creating bottlenecks and they call for a new machine or a new way of handling things, a new way of production. These are the reasons why plant layout is needed. There are different types of layout. We have grouped here 4. We have already given idea about what a product focused system is, and that calls for a product layout, and a process focused system goes for a process layout. Apart from these two, there are 2 other layouts, fixed layout and group layout. Let us see what they mean. In a product layout, the machines are arranged according to the sequence of operations of a product or a group of related products. That means, the sequence of operation is fixed, even if the product is one or a group of products, they must have the same sequence of operation. If the operation sequence is known, then the machines are arranged according to the sequence. They are naturally applicable for continuous production, and product layouts can be both in production lines or assembly lines. That means, parts are made and then assembled, that is normally called an assembly line, and while production takes place, it may be done in a sequential manner. It is a production line. Now, this is an example of a product that passes through these different machines: lathe, milling machine, drilling machine, shaping machine, grinder, then milling machine again, drilling, grinding, and then finally packaging. So, this is the sequence of operation, and therefore, machines are laid out in this fashion. In a process layout, which is also known as a functional layout, facilities are grouped according to functions. That means, departments or sections are formed. They are good for products that differ in their operation sequences, meaning custom products, in which the specifications are different, the designs are different, and the operation sequences are also different. Here is an example. The milling machine is, all milling machines are put together in one place, all sewing machines, all drilling machines, all automatic machines are separately placed, and a department for receiving and shipping. Fixed position layout. Normally, very heavy and large size products such as a ship or an aircraft, they are very large and very heavy. So, normally they are put in one place and different processes serve the production need for the product. So, this is a fixed position layout. Workers, materials and equipment are all brought to the location for processing the product. A fourth layout is called a group layout, in which families of parts are processed in cells of machines. Parts that are similar, perhaps different in sizes or types of the same product, and they are processed in cells or groups of machines. Now, you see L lathe, milling machine, another lathe and drilling machine, they are put in this cell or group. So, the product that comes here goes to this lathe and then to the drilling machine, then to the milling machine, then goes away. So, this may not require another operation or use of another lathe, but a second product of the same type may require to go through still another lathe and go out. A second product may go through the second cell, lathe, milling machine, another milling machine and a drilling machine, and then goes out. So, this is called a group layout because the operations required are similar in nature. Products of those type come here, a product of another type comes here, and a third type comes here, and a fourth type comes there. Now, we can compare between the product layout and process layout. These two are the predominantly the layouts that are used in practice. In a product layout, the material handling cost is low, in process inventory is low, production control is simplified and less space is required. And in a process layout, the machine utilization is high, the flexibility must be high, there must be another machine available when it is breaking down, because all machines are in one place and one should go for individual incentive scheme. Now, normally before one decides the way the machines are to be laid out, a product analysis is required. Normally graphical presentations are done, one at the assembly level and the other is at the each operation level. Accordingly, it is called assembly chart or goes into chart. Goes into basically goes into, GOES into, goes into. It shows how flow of material and relationships of parts. And operation process chart is basically a graphical representation of the operations that take place when a process, a part is produced. Let us give an example of goes into chart. This is also known as an assembly chart. These symbols are for the components. So, this is a component. So, they are all bought from outside and these are the operations. Of course, I have not written down the names of the operations, but one should write the names of the operations. So, these three parts together form a sub-assembly. This part or component goes through two operations, this sub-assembly and this part after two operations go through another operation and then it is tested. So, this symbol is for testing, this symbol is for sub-assembly and the circles for operation. Like this, another sub-assembly here out of two bought out components, this and after testing and another operation, this goes through another operation and then this part and this through this operation and finally, the testing is done. You can now understand why it is called a goes into chart. These components goes into this process, this goes into the sub-assembly and then into the process and finally, to the assembly. So, this is a broad view of how components and sub-assemblies go through different operations to produce the final assembly. They goes into chart. Now, in this, let us consider how these three components are go into the sub-assembly 1. This is shown here. Sub-assembly is made here and the three components are this component 2, 3 and 4. Component 2 passes through 3 operations and a testing. Component 3 passes through 2 operations and a testing. Component 4 3 operations and a testing, and then all of them pass through another operation and then a testing before they form a sub-assembly 1. So, you can see that it is further broken down into individual operations. This is how an operation level analysis is done. So, you can see that we are following a top down approach, in which the first the assembly level details are found out through the goes into chart, and then we make an operation level analysis. That means, we break down the subassembly into different parts and find out how the different components pass through different operations, and then they are assembled into subassembly. So, operation chart can be very big, but I have only shown only for subassembly 1. Normally, in a product focused system, the proper layout is a product layout or a line layout. So, there the problem is whether the line is balanced. You can know that every operation takes a time that can be different from the operation which is next to it. So, unless the two operations are equal in nature, if every operation is given to one machine, then it is possible that there is a mismatch of the time, and therefore, a machine may remain idle because the operation in its previous machine is not yet complete. Now, this idle time is the problem in a line layout. Therefore, in a line layout, it is required to make the design of the line in such a fashion that the delay is the minimum. Particularly in assembly, there is a possibility of bunching certain operations into a particular station, and the station times should not be very different from one another. This is called the assembly line balancing problem. Now, here normally the products are assembled in a continuous conveyor line. There are several workstations along the line. Several operations or tasks are assigned to each workstation subject to the constraints that the operation sequence is maintained and that each workstation takes roughly the same time. There can be other considerations, but principally these two considerations are important, that the operation sequence must be maintained and the workstations must be balanced, meaning that roughly they should take the same time, and that each workstation can or should handle one or more than one tasks or operations. So, in which way the operations should be grouped so that these two are achieved. The other considerations are that there could be a zoning constraint, or that certain tasks must be done at specific locations and all that. They are more difficult to handle, but this is easier things to handle and we will study that. We are illustrating this with the help of an example. Consider a 9 task assembly problem. A task is also known as a work element. So, these tasks are A, B, C, D, E, F, G, H, I, and the duration in minutes are given here, and the immediate predecessor is this are these, meaning that to carry out B, A must be completed. So, A is the predecessor of B. To carry out C, A should also be completed, only A, not B. So, A is its immediate predecessor. To carry out D, we need to complete both B and C, otherwise D cannot start. So, I cannot start unless E, G and H, all the three are complete. Normally, this is shown in the form of a diagram. Here you see it says that once A is finished, B and C can start, and when both B and C are complete, D can start. When D is complete, any one of these three can start, E, F and G, but not H. H can start only after F is complete, and only when E, H and G are complete, I can start and complete. And these are the times that I had written down in the table here, the duration times. Now, assume that the output requirement is between 4 to 5 units per hour. I am sorry, these are all hours, 5 hours, 3 hours, 5 hours, 4 hours, etc. No, these are minutes, these are minutes. Let us say that the output requirement is 4 to 5 units per hour, resulting in the desired cycle time of 12 to 15 minutes. If in 1 hour 4 units are made, then per unit it is 15 minutes, whereas if it is 5 units it is 12. So, if the output requirement is between 4 to 5 units, the cycle time has to be 12 or 15 minutes per part. Now, the total time comes to, if we add all this, comes to 37. 5 plus 4, 9, 12, 17, 21, 22, 26, 32 and 5, 37. So, total 37 minutes. We are interested to group these operations or tasks or work elements into different sets and assign each set of tasks to one particular workstation, such that the station time is between this. So, the total number of tasks is 9, total task time is 37. If we go for 2 stations, every station can have a something like 18.50 minutes, but we need something between 12 to 15. If you go for 3 workstations, then it is 12.33 minutes, and if you go for 4 workstations, it is something like 9.25 minutes. 37 divided by 4, 37 divided by 3 is this. So, it appears that if we go for 3 workstations, we can get the required output. The question is how to group the operations into each of these 3 workstations. Now, here we have given an example. Suppose that we go for 2 workstations, workstation 1 and workstation 2, and suppose that we arbitrarily assign A, B, C, D and E. Let us look at that. Yes, this one, A, B, C, D and E, these 5 we assign to workstation 1. That means, these tasks will be completed in workstation 1. So, they will take 18 minutes, A takes 5, etc., and the remaining time workstation 2 takes 19 minutes, and the cycle time, that means, the work will be completed after 19 minutes only, that is called the cycle time. The cycle time is therefore 19 minutes, and the idle time of machine or workstation 1 is 1 minute. For 1 minute it will remain idle, and workstation 2 will be always busy. Of course, we need 3 workstations and not 2. Now, we use a balancing heuristic given by Moody and Young. It says, first of all, assign task A, we assume that to be equal to 14, assign task A to station 1 that does not have a predecessor. So, first task A does not have a predecessor. So, assign that to workstation 1. So, the station time is 5. Now, find the successor tasks B and C. Look at this diagram. After A is complete, B and C are available, B with 3, C with 4. The heuristic says find out of these B and C the task with the highest task time. In this case it is C, that has 4 minutes. Assign that also to station 1. So, the station 1 total time becomes 5 minutes for A and 4 minutes for C, making it 9 minutes. So, now that A and C are both assigned, the immediate predecessors successors are B and D. However, D cannot be between these two, D has higher value 3 and 5, 5 is higher. So, D could be assigned to workstation 1. However, D has a predecessor B and B has not been yet assigned. Therefore, unless B is assigned, D cannot be assigned. Hence, B has to be assigned to workstation 1 according to this heuristic. So, that is what we have written. Although D satisfies this criterion, higher of the successor tasks, it cannot be assigned. Hence, assign B to station 1 and station time becomes 12. We are interested in the cycle time between 12 and 15 and we are suggesting that it should be 14. Now that we have assigned B, we can now think of assigning D, which is its successor, but D when applied to station 1, its station time becomes 17, much in excess of 12 to 15. Therefore, D cannot be assigned to station 1, it should be assigned to station 2. So, assign D to station 2, therefore, the station time of station 2 is 5, the task time of D, and the immediate successors of D are E, F and G. Of these three, G is having the highest task time. Therefore, easily G can be given to workstation 2, making the station time 10. Now, we have the successors are E, F and I, but I cannot start unless H is complete. Therefore, I is out of question. We have to think between these two. Between these two, F is higher. So, F probably can be given to workstation 2, making the value 5 plus 5 plus 4, 14. The remaining tasks are assigned to station 3, station time is 11 minutes. So, now we have 3 stations and we have followed the Young and Moody's heuristic to assign the tasks to different workstations, resulting in 12 minute, 14 minute and 11 minute. And the cycle time is the highest of the 3, which is 14 minute. And compared to this, the idle times for workstation 1 is 2 minute, workstation 2 0 minute, workstation 3 3 minutes. Now, we see that the loading of the workstations is uneven. It is not very good, because the difference is here 3 minutes, 2 minutes and 0 minute. Now, we can use our judgment to trade and transfer the stations among stations. For example, G from station 2 and H of station 3 can be traded and transferred. G has got a time of 5 and H has got a time of 4. And if we look at the precedence relationship, once F is complete, G and H can be put anywhere. So, we are putting G here and H here. So, resulting in 13 minutes here and 12 minutes there. The cycle time reduces to 13 minutes, therefore, the production time will improve. The idle time is now reduced to 1 minute for workstation 1 and 1 minute for workstation 3, and here of course it is 0 minute. Normally this unevenness, so the improved balance is I have given here. Therefore, we normally define a term called balance delay and define it in this fashion, that it is 100 into N c minus summation T I by N c, where N is the number of stations, in this case 9, C is the cycle time. The cycle time we have got is 13 minutes. So, 13 multiplied by 9 is N into C, minus total time is 37 divided by N into C, which is 9 into 13. This in our case comes as 5.4%, and with a cycle time of 13 minutes, it will give us 4.6 parts per hour. So, friends, today what we did, we started with the broad product service strategies that an enterprise can take. As I said, it depends on principally two things. One, the stage of the life cycle and the nature of the demand, low volume or high volume, or custom products or mass products. Depending on that, the company can go for either intermittent production or continuous production, or in between batch production or mixed production. We talked about 4 different types of layout. For standard products, we followed product layout or line layout. For custom products, we follow process or functional layout, and then there are 2 other varieties, fixed layout and group layout. Towards the end of the lecture, we discussed about particularly a problem that is encountered in assembly lines known as line balancing problem. There the problem is how to group different operations and assign them to different workstations, such that the workstation times are more or less equal. We defined a quantity called balance delay, which can be used to compare between different allocations, and normally one uses different methods by using judgment known as heuristics to decide how to group the operations or tasks and assign them to different workstations. In our next class, we shall discuss about how to make process layout decisions, and after that we shall start discussion on production planning. Thank you very much.